Welcome everybody. So this is my Azure AZ900 Azure Fundamentals full course. Basically, I'm going to be going through all of the content in the AZ900 and going through everything you need to know to pass the exam. I've been working in security for 3 or 4 years now, and before that I was working in regular IT, working within an infrastructure team for 2 years before that. So I'm still fairly new in my career, but I thought what better way to consolidate my understanding than to basically make my own course for this. And although a lot of the concepts in this certification exam are quite high level, it's a really, really good place to start to get into Azure. So the structure of this course, we're going to basically go through what the exam format is, then we're going to go through the exam objectives, and then we're going to get right into the content. Throughout, we're going to be jumping between various diagrams as well as some actual demos of the Azure portal and sort of spinning up resources and managing the various concepts as we get through. Now, that's not a requirement for this exam. You're not expected to do anything like that. You're not expected to lab it. And honestly, you don't need to lab it to pass. But I find for me, the best way to learn this stuff is familiarity. So we're going to go through that. So the objectives for this exam, the first one is describe cloud concepts. That's going to be 25 to 30% of your exam. Describe Azure architecture and services. That's going to be 35 to 40% of your exam. Describe Azure management and governance. That's going to be 30 to 35% of your exam. And these are basically really high level. These are like the main modules in the exam, but they're going to break down into much, much smaller headings and then even subheadings below that of different concepts, architecture and services, and management and governance requirements. So we'll go through them as we go through the different sections. So the exam format, the passing score is 700 out of 1,000. Basically, you're only going to get asked 35 to 60 questions, but each question's weighted a different amount. So not each question is going to be worth the same amount of points, which is why it's 700 out of 1,000. As long as you answer 70% of the questions correctly, roughly, you're going to get the pass mark on it. So the exam can be taken remotely or at an exam centre. For me, I sat this one remotely. I've sat 2 exams remotely now, and although I've had a few minor hiccups, I still prefer the remote exam, mostly because there's no test centres near me. So my closest test centre is an hour away. So although I have to go through all the hassle of clearing out my desk, unplugging my monitors, taking pictures of all my walls and taking pictures of my ID, it's still much, much less time than if I was to trek out to an exam centre. But it's all down to what you prefer. A lot of people like to do the exam centre because it's not a much more relaxed environment. Maybe your house might be more relaxed for you, but basically it's going to be a more controlled environment. If your internet cuts out during your exam or you have internet issues, you're going to have to basically delay the exam or your exam might even be cancelled. As well as it's much easier to get disqualified in a remote exam, I've heard. I know a lot of people who have had issues with remote exams and so they tend to shy away from them. But personally, I've never had an issue yet. So our first module we're going to be going into is describe cloud concepts. So the sort of sub modules in this are going to be describe cloud computing, describe the benefit of using cloud services, and describe cloud service types. So what is cloud computing? Cloud computing is the delivery of computing services over the internet. An example of this would be AWS or Microsoft Azure. Of course, this is going to focus on Azure. There's AWS certifications though that you can do, but this is going to be focusing completely on Azure. So a lot of the concepts are transferable though. It's just the actual nitty gritty of how you actually do things, or different product names might not be the same. So basically, it can provide benefits over traditional on premises infrastructure. The main benefits of cloud computing would be rapid scaling, both vertically and horizontally. So if you need more resources very, very quickly in a traditional infrastructure, you need to have pre-planned for that, right? You need to have spare space on your hypervisor as far as computing power goes, or you need to have spare servers if you're really old-fashioned, you're running individual physical servers. But usually you'd have to have a very high-spec hypervisor that you could then spin up VMs on. And even then, you have to account for all that, right? What happens when you get to the end of that? You get to the max of that power. Well, you kind of got an issue there because, look, you don't have any more servers. But with cloud computing, that's not an issue. You can just spin up VMs very quickly without worrying about having to provision new hypervisors in your data center. So that's a really, really big benefit. Again, maybe that's not an issue. Maybe you're really well budgeted in your organization and you've got a lot of computing power. So making more and more VMs, it's not going to be an issue. But what happens in times of sort of lower traffic? Well, you've got servers sitting there that you've wasted a lot of money on and you're not utilizing them. But with the cloud, you can scale that right back down again and only provision what you need. And there's a lot of services to help with that. They can kind of spin up stuff on demand, kind of as traffic's rising, and then automatically scale it back down. So there are a lot of benefits to cloud computing over traditional infrastructure. That being said, there are benefits the other way, and we'll get into that later on. So one of the main concepts of the cloud is this shared responsibility model, basically meaning patching and maintaining systems and infrastructure, well, it's shared between the customer and the provider, all right? So responsibility is always going to be retained by the customer. So information and data, devices, mobiles and PCs, and accounts and identities, you're always going to be managing this as the customer. And the cloud provider, Microsoft in this example, they're always going to be managing the physical host, the physical network, and the data center. Now, depending on which actual sort of model you're using, there's going to be identity and directory infrastructure, applications, network controls, and operating systems. That's going to vary. So infrastructure as a service, you actually manage your own operating systems and your VMs. But on platform as a service, that's all managed by Microsoft. And we're going to get into that sort of stuff a little bit later. So there's three main cloud models. There's a private cloud, which is basically managing your own data center, right? It is managing your own data center. Private cloud is just a fancy way of saying you've got your own data center. You spin up your own servers, you spin up VMs on those servers, you manage your networks, you manage your power, your cooling, all of that. The public cloud, well, Microsoft manage their own data centers and they manage all the cooling, they manage the physical security of the data center. They add the new servers and you can rent out resources on those servers. And that's what Microsoft Azure is based off of, right? It's all about they've got all these massive data centers and they're renting you out parts of their computing power. Now, hybrid cloud is when you've got a mix of both. You've got some on-prem infrastructure, but you've also got some in the cloud. There are a few other models of cloud. There's the multi-cloud, in which you have multiple public clouds, and there's also Azure VMware Solutions, which runs on EXE for hypervisors, and, well, it only runs on EXE hypervisors. That's a bit more of a niche solution, and you might probably find yourself never having to use it, but it's there if you need to. So there's going to be a few different features of each cloud model. So for the public cloud, there's no capital expenditure, meaning you don't have to pay for your physical servers and you don't have to pay for all the startup costs associated with a physical server. You only need to pay the costs of running the VM and storing the resources. So it's going to be something you pay monthly, but there's going to be no massive upfront costs, which is a big benefit. You can scale up and down quickly to meet demand. You only pay for what you use. That's what we're talking about, capital expenditure and operational expenditure. We'll go into them later. But you don't have control over the resources and the security. You don't have full control anyway. So the private cloud, you do have complete control over your resources and security. Data isn't collated with other organizations' data, which is a big plus for security and data privacy. Capital expenditure, well, you have to pay for your servers, right? So if you want to if you want to double your sort of power and you want to double the amount of compute power you have, you're going to have to buy a bunch of massive hypervisor servers, and that's going to cost a lot of money up front. You're not just paying for the resources you're using, you're paying for the maximum load of resources you want to be able to support. You're also responsible for patching and hardware maintenance. So if a disk dies in a server, you're going to have to buy a new disk or you're going to have to get that sorted out. It's also slower to spin up resources. So the hybrid cloud is the most flexible. You can choose where to provision services. So for example, say you want to spin up a VM. Well, you don't really have a lot of space on your data center. You don't have a lot of power left. So you can just spin one up in the cloud. It's really, really easy. Yeah, so those are the main cloud models. So now we're going to talk about the consumption-based model. So there's two types of, expenditure models in the consumption-based model. CapEx, which is one-time upfront payments. That's like buying new servers or security systems. And OpEx, operational expenditure. That's the cost of the service over time. With the consumption-based model, which is what Azure runs off of, there's no upfront costs. There's no need to maintain large data centers, which won't always be used to its fullest potential. You can scale up and down as needed. High availability is basically making sure resources are available regardless of disruption. So high availability is one of the main sort of concepts of Azure, and I'm going to be saying that throughout this whole course. And that's because this is Azure fundamentals, right? This is the stuff that builds up of Azure. So high availability is kind of working around making sure that stuff is available for the customers, right? And their service isn't impacted. So say a VM drops down, well, there's going to be another VM to take its place. And that's okay. So we can actually do a bit of a diagram here for high availability. So basically here you've got your region, and that's a lovely square. And apologies for any drawings. I'm not very good at drawing. Okay, so we've got a region here, and again, I'm not very good at handwriting either. So we've got a region, call that region 1, and inside that region we have got a data center. So data center 1, data center 1. Now, inside you might have a VM, and cool. So if that VM goes down, you're going to lose all of your availability. And if the data center goes down, you're going to lose all your availability. And if the region goes down, you're going to lose all of your availability. So there's a number of different kind of outages that could knock us down basically at this point. So with high availability, well, let's add another VM in there. So now we've got 2 VMs. And let's add another VM in there. And so we've got 3 VMs in that one data center. So say one of the VMs goes down, we've still got 2 more. And if the data center goes down, well, we've lost our VMs. And if the region goes down, well, we've lost our VMs. So with high availability, what we can also do is we can set up an availability zone, which is within the same region, but it's a different data center. And in there we have VM, we have VM, and we have VMs. So we've got another 3 VMs in there. So now that's going to be data center 2. Data center 2, if you believe that says data center 2. And so now if one of our VMs goes down, well, we've got other VMs in the same data center. If that whole data center goes down, well, we've got a whole other data center that has more VMs in. So that's kind of the premise of high availability. I mean, even if our region goes down, well, there is region pairs, but we'll talk about that at a later date. That was a quick overview of high availability. Scalability, it's about adjusting resources on demand, right? So when demand's high, resources can be scaled up, and when demand drops again, you can scale right back down. Vertical scaling is when you add more resources to a single resource. Well, maybe resources to resources isn't a good example. You add more CPUs and RAM to a virtual machine, for example. Horizontal scaling is adding more VMs to help tackle demand and remove them once things settle back down. So you might be happy or very unhappy to see this next screen, which is another whiteboard screen. So we're going to look at scalability quickly. So there's 2 different types of scalability. Scalability basically refers to adding more resources to meet demand and then scaling back down when they're not needed, so you're not paying for unnecessary resources. So say you've got a VM here. We'll call that VM. And vertical scaling refers to adding more resources to that single VM, right? So you can add like a CPU, pretend that's a CPU, and we're going to add more RAM in as well. And we can just scale vertically like that, okay? To the point where we've got 1 VM and it can do a lot, right? Because we're just adding RAM, we're adding RAM, and we're adding more CPUs. So we've scaled it vertically, right? So we're basically adding more computing resources to that 1 VM. But that's not always going to fit our use case, which is when horizontal scaling comes in. With horizontal scaling, we just add more VMs out the way, right? So we add more VMs, we add more VMs, and we add more VMs. And you've got 4 VMs now. So scaling vertically, adding more resources to a specific VM, and scaling horizontally is just adding more VMs. Reliability is the ability for a system to recover after a failure and continue to function. This is the feature of the cloud by design. Resources can be deployed in regions around the world, allowing for other regions to be used if one goes down. Predictability focuses on 2 things: performance predictability, which focuses on resources needed to provide a positive customer experience, such as auto-scaling, load balancing, and high availability. And cost predictability, forecasting the cost of the cloud spend. Costs can be tracked in real time using the total cost of owner, TCO calculator, and the pricing calculator. These are covered later in the course. So security and governance in the cloud. Governance, when deploying resources, set templates can be used to ensure resources meet corporate and government standards and regulations. Resources can be updated easily when new standards are released, and cloud-based auditing can flag resources out of compliance. Security, flexible security solutions based on your development model. Infrastructure as a service if you want to manage your own patches, and platform as a service if you want patches managed for you. Again, we'll go into those 2 concepts later on. So the management of the cloud. There's a few ways that you can manage cloud resources with automatic scaling, deploying resources using templates, allowing you to deploy them in a consistent manner, monitor the health of resources and automatically replace failing ones, and receive automatic alerts on pre-configured metrics, allowing reporting in real time. Management in the cloud. So there's multiple ways you actually interact with the cloud and manage cloud resources. First being the web portal, portal.azure.com. You can also use the Cloud Shell, so command line interface. There's also sort of CLI tools you can install to your machine locally. You can use API and you can use PowerShell as well. So when you go to portal.azure.com, this is actually the screen you're going to be met with. I have removed my search bar and my bottom taskbar just because you see 100 million things that I have open at a time. But this is kind of the main landing page of Azure. So you're going to see we've got Azure at the top. This opens this little sidebar. You can see at the top here you can access the Cloud Shell. This is for switching directories. You've got your notifications to your settings. You've got help. And what's that? Support maybe? Oh no, it's feedback. Up here you can see basically this is the actual account I'm logged in at, and then this is the actual tenant. So I think that's a lot of information. Ooh. Not sure if I was meant to show that. Oh well. Okay, so here we've got more services, and this is going to show you basically almost everything you can configure in Azure. So it's separated into general, which is a lot of the sort of, well, the general sort of Azure specific stuff. Then you've got compute resources, such as virtual machines, containers. Then we go into like desks, function apps, app services, Kubernetes, which is for like infrastructure as code type stuff. Then you've got all your networking, you've got virtual networks, you've got network security groups, network interfaces, load balancers. So we spoke about sort of high availability before. And if you're sort of serving high availability to customers, you can basically stick all your high available VMs behind a load balancer, and that's going to split all your traffic nice and easy for you. Local network gateways, that's basically for if you're wanting to connect with an on-prem VPN, basically set an actual encrypted VPN tunnel to your Azure tenancy. We've got storage, web, mobile, we've got a lot. There's just a lot you can figure within Azure. Here we've got Azure Active Directory. There's going to be more sort of more in-depth and more specific sort of Azure demos as we go about the course. So this is just a really quick overview of navigating the Azure portal, and we're going to get into more later on. So now we're going to go into cloud service types. So infrastructure as a service, or IaaS, the cloud provider is responsible for the hardware, the network connectivity, and the physical security, whereas the customer is responsible for the operating system installation and patching. So VMs are a IaaS, I guess, service type, where you're responsible for the operating system, you install the operating system, you install and manage all the patches on that VM, but the cloud provider actually manages the physical hardware. There's platform as a service, where cloud providers also handle the operating system and the tools, meaning you can just put your application on there and bish bash bosh. And there's software as a service, where it's sort of a complete experience. And this is kind of like Office 365 as a software as a service, right? You pay a monthly fee for that, and you get a complete application that you just get to use out of the box with a little bit of configuration. So here's some use cases for the different service types. So IaaS, infrastructure as a service, a lift and shift migration when you want a similar experience to your on-prem setup, configuring a similar setup in the cloud, and then moving the services over, and also testing and development. If you're sort of developing something and it's important to test the setups in different environments, different operating systems, or legacy operating systems, these can be rapidly spun up and decommissioned with IaaS. This gives you a lot of flexibility in how you're testing things. There's also platform as a service, so development frameworks are provided, allowing developers to use built-in software components and reducing coding work. There's also analytic or business intelligence you can use with PaaS. PaaS tools allow for organizations to mine, analyze data, allowing for better forecasting. And then there's software as a service. Well, you can get software as a service for basically anything, but some of the main ones would be email messaging and finance and expense tracking. So now we're going to move on to the second module of Azure Fundamentals. This is the biggest one by far. It's probably double the size of the other two. They probably could have broken this one down into a bit of a smaller one. But the main sort of topics in this module are going to be describe the core architectural components of Azure, describe Azure compute and networking services, describe Azure storage services, and describe Azure identity, access, and security. So Azure regions speak to where resources are deployed. So if you're in Australia, you probably don't want to be deploying resources to central US unless your users are going to be there, your customers are going to be there. So you basically want to deploy resources closest to where the people using them are going to be. This is called geo-distribution. Basically, a region is an area on the planet which contains one or more Azure data center. Not every country in the world is going to have an Azure data center, though this isn't the most up-to-date image in the world. There's probably a lot more now, but not every country is going to have an Azure data center, and even the ones that do, sometimes they only have one. So not every country or region has multiple data centers either. So, region pairs. Most regions are paired with another region in the same geography. So if a massive outage hits a region, the resource can fail over and continue working in the second region in the pair. You can't select which region you're paired with though. So within an Azure region, you've got availability zones, which we're going to cover later on, and then we've got a region pair here. So we've got 3 availability zones in the primary region, 3 availability zones in the secondary region. So say everything drops down in our primary region, our VMs are going to our resources or VMs. I keep saying VMs, but VMs aren't the only thing you can configure in Azure. It's just kind of what I go to because I come from an infrastructure background, right? But all your resources are going to fail over to the secondary Azure region. Like I said, you cannot select which region you're paired with. A sovereign region is completely separate from the main instance of Azure. It might be needed for legal or compliance reasons. I know US government officials have this, and I'm not actually sure where else has this. I think maybe China does, but I could be making that up. Azure data centers, they're similar to on-prem data centers, except on a much larger scale, using miles and miles of warehousing. Like if you've seen like kind of the Facebook sort of data centers, it's a similar sort of thing, right? Where it's just miles and miles of servers. It's used to host Azure resources. It's basically a large facility, lots of high-powered machines with dedicated networking and power. An availability zone is a physically separate data center within an Azure region. It's made up of one or more data centers. You can't have an availability zone if the region only has one data center in it. If one data center goes down, services can continue in the sort of second zone in the availability zone, and it's only available in regions with multiple Azure data centers. Resources and resource groups. A resource is anything that is created or deployed within Azure, and a resource group is a way to logically group resources. When you create a resource, you need to put it in a resource group. They can't be nested. Actions applied to the resource group apply to all members of the group, and when deleted, all resources within are going to be deleted. When granting access to a resource group, access applies to all resources within. We're now going to look at basically configuring a resource group. So basically what you do is you want to go to create a resource here, and you can see we've got 100 different kinds of resources. We're going to do a resource. Okay, maybe not. Okay, up the top, we're going to do resource groups. Okay, blah, 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 blah. Cool. So you want to hit create up in the corner here, and that's just going to basically ask us which subscription you want to go to. You want to basically name your resource groups. We're going to call it ZSEC -RG for resource group, just a bit of a wee naming scheme there. I'm in the UK, so we're going to put it in the UK. Next, tags. So you could do a tag to basically chat who the owner is, or some other tag to maybe set the department, but we're not going to do any tags just now. We're going to review and create. It's going to do a little bit of validation to make sure we've actually filled in every required field, and we're just going to hit create there. And then from there, we've got resource group, and that's just going to group all our resources. Like I said, these can't be nested, so you can't make a resource group inside a resource group. And if you delete this, it's going to delete every resource that you've put inside this resource group. So that's something you need to be careful with. Subscriptions. So subscriptions basically allow you to organize resource groups and billing. At least one subscription is required per Azure tenancy. There's separate billing per subscriptions, and it allows you to manage access control. So here they've got their Azure account, and they've set up 3 subscriptions. So they've got one for devs, they've got one for testing, they've got one for production. One, this is to separate billing between all of these, and it's also to separate who has access to these. You can do this more granularly. I've not been to a lot of places where we're using multiple subscriptions. We tend to just use the one, and then we manage our own access within that, but it sort of depends on your use case. Management groups. So resources are grouped into resource groups, which are grouped into subscriptions, and subscriptions can then be grouped at higher level into a management group. So subscriptions inherit government from a management group. They can be nested. Up to 1,000 can be supported in a single directory, but they only support up to 6 levels of depth, not including the root directory, and each management group and subscription can only have one direct parent above them. So here's an actual diagram of management groups. So you see you've got your root management group here, then we've got one for human resources. Inside there, we've got a subscription for dev test, and then we've got another management group for apps. Then here we've got an IT management group, then a production management group, then a GeoRegion 1, GeoRegion 2 management group, and a bunch of other subscriptions. So bearing in mind you can only go 6 down here. So this is actually 4 in depth, not including the root subscription. So 4, and this can go in 6 in depth. And basically it's a way of kind of tidying things up and keeping things logically separated if you need a lot of subscriptions. So virtual machines. Yeah, and you'll know virtual machines now because it's all I've been talking about. Every slide I'll say, oh, you can do this with a virtual machine. Virtual machines. Okay, so Azure Virtual Machines allow you to virtualize a machine in the cloud. Azure handles the hardware while you manage the OS you install and everything above that. So the use cases for this would be developing and testing configurations on different operating systems, hosting applications in the cloud, or extending your on-prem data center via the hybrid model. So considerations when creating a VM: the name of the VM, the location the resources will be stored in, which is in like the region, which size of the VM, operating system the virtual machine will run, and the configuration of the VM once spun up. So availability, you can do availability zones. So if a VM knocks down, it can basically fall over to the second zone in the availability zone. And scale sets. Basically, if you need to provision a bunch of identical VMs at once, you can do that with scale sets. VM pricing is based on the resources assigned to it, so CPUs, memory, storage, networking, and this is charged hourly while the VM is running. Storage in the VM also needs to be paid even when the VM is paused. So although the bulk of your pricing and your costs might be the sort of resources running the VM, even when you stop the VM, you're still going to be paying storage on it. So that's just something you need to bear in mind. Next, we're going to look at installing virtual machines in Azure. So basically, you want to go to virtual machines here. If it's not there, search up in the top bar. You want to hit create, and we're going to choose a virtual machine. There's multiple different sort of deployment options. We're just going to do the regular where we configure it all ourselves. Resource group, we're going to select our ZSec resource group. We're going to call it VM1. UK South region, so you can set your availability zones. So if a data center goes down, you can fail over to another availability zone within the same region. We've got scale sets for sort of distributing VMs. We've got availability sets for sort of fault domains, and we're going to do standard level security. The image, we're just going to choose. We're going to choose Windows 10 Pro. Are we? Are we going to choose Ubuntu? Should we do Ubuntu or should we do Windows? Let's just do Windows 10 VM for now, even though they're a lot bigger. So you set your size here, so you can see all of your sizes. I'm not too I'm not too sure on what the sizes are. Okay, let's. What's your lowest cost size? He asked. Okay, I see. Cool. There's a lot of sizes here. Cool. So we'll just choose this one. General purposes, 2 virtual CPUs, 8 gigs of RAM, 4 data disks, max IOPS of 3200, temp storage of 16 gigs, premium disk supported, and that's going to be about $81 a month. Of course, this isn't actually going to run for the month. We're going to create it and then we're going to blow it away again. Username, well, we'll just do administrator. Again, I don't recommend calling your admin account administrator. Oh, you can't do it. ZSec main boy. And the password is going to be a password. Needs to be longer. Cool, they're matching. Inbound port rules. So basically, if you want public inbound port rules, you want to basically see if it's going to be accessible to the internet. So we can select sort of inbound 3389, which is RDP. And so this basically allows all IP addresses to access the virtual machine. It basically makes it internet accessible or internet routable. We're not going to do that for now. We're going to do none just because I don't want to deal with the whole hardening of the VM stuff. And yep, we're going to say that we're eligible. Okay, next you're going to do the OS disk. We're going to just do a standard HDD. We're going to delete it with the VM. We're going to do platform managed keys, and we don't care about disk compatibility for now. There we're going to do next. So networking we can do to our ZSEC VNet1, which we made in the future, but actually in the past. Inbound rules again, you can select your ports. So if you want HTTP, HTTPS, SSH, or RDP access to the box, we're not setting that up just now. Okay, if you're actually going to be accessing them, you're going to want to set this stuff up. But for the sake of demo purposes, we're just not going to accelerated networking. We'll just disable that for now. We're not going to do any load balancing for now, but Azure load balancer's there and an application gateway's there. Next management, so basic plan for free. There's a lot you can actually set in to log in with Azure AD and use RBAC, role-based access control. We'll actually cover that later. Disaster recovery. So when you're actually deploying this all in prod, you're going to want to think about a lot of this. Because it's this for demo purposes, I'm just showing you how we actually go through this. We're not actually going to. Okay, advanced, blah, blah, tags, review and create. What are we missing? Like, we'll be missing disks, but this is going to load quickly. I mean, you can already see this is going to be 0.1110 USD an hour. So it's not super expensive, but if you keep it running, then it is going to be expensive. So we're going to make sure not to. And you just want to hit create there. So that's going to spin up our VM. And probably would be quicker if we were doing like a Ubuntu VM, but we're not. We're doing a Windows VM, which is going to be a bit of a higher profile. Submit deployment. So deployment is in progress. You can see the start time. Hopefully it should finish pretty soon. Okay, so you can actually see it's basically deploying like our IP addresses, network security groups, network interface, virtual machine. You can see it's deploying the various things, and this is all gonna end up in our resource group basically, because well, we've all put it in the ZSEC resource group. Like I said before, everything needs to go in a resource group, so you can't avoid it. There's no getting around resource groups. I quite like it. I like to be forced into certain situations so that I don't do bad practice, like not using resource groups. So after a few minutes, our deployment is complete. We're going to head back to Azure. We're going to go back into VM1 here, and we can basically see it. So you can VM virtual machine agent status is not ready. Troubleshoot the issue. I'm sure that's probably because I basically put no access to it, so I'm not going to be able to connect it or anything. But it could actually just still be configuring. With Azure resources, you kind of want to give them 10 minutes or so, even when they're actually deployed, because a lot of time they're still actually spinning up and configuring stuff. But yeah, so that's the general idea. That's your VM. If you did add some inbound rules, you can actually basically connect, and then you'd either deploy your RDP file, or you would connect via SSH, or you could use Bastion. So yeah, that's VMs. Okay, so we're finally going to talk about something that's not a VM, or a resource that's not a VM. So containers, they're similar to a VM, but you don't actually manage the underlying operating system. You basically you can just spin up the applications directly. So the benefits are they're lightweight, agile, and easy to scale. It's a good option for developers that don't want to manage an underlying OS. They're also really easy to blow away. I know that's a benefit of VMs too, but even more so with containers. It's really easy to just blow one away and open up a new one. So functions. So functions are event-driven, they're serverless, there's no maintenance of underlying OS or containers that have to be kept running. They basically sit dormant, waiting for a specific event to activate the function, and then this saves resources. So once the function is sitting listening, it sort of executes its little bit of code, then it just goes back to chilling, listening again. So you're saving resources there. It can be stateful or stateless. Basically, stateless behaves as if it's been restarted every time an event triggers it, and stateful means that prior events and contexts are taken into account. So we touched earlier on virtual machine scale sets a little bit, but they're basically groups of identical virtual machines that can be put into scale sets. When demand increases, new VMs can be used to increase the capacity. It provides high availability, scalability, and redundancy. They're load balanced, and it allows you to quickly scale up and back down again. An availability set is a logical grouping of VMs. So it basically provides redundancy and availability. Each VM in the set is assigned an update domain and fault domain. Update domains are groups of VMs and underlying physical hardware that can be rebooted at the same time. Each VM within a single availability set is assigned to one of their 5 update domains, with the 6th VM being placed back in the first update domain, and it just kind of goes like that as you add each more layers like that. This allows for VMs to be taken down in groups for updates while still providing availability. A fault domain defines the group of VMs that share a common power source network switch. By default, VMs within your availability sets are separated across these 3 fault domains, and availability sets don't protect from application or OS failures. So here's a little diagram of an availability set. So you've got 3 fault domains here, but then within that you see there's various update domains. So you've got update domain 1, update domain 2, update domain 3, 4, 5, and 6. But number 6 you see falls back to the first update domain. So we've got fault tolerance here, but then we've also got update domains within this. So these basically when these are updated, this VM1 and VM6 are in the same update domain, so they'll go down at the same time to be updated. It's pretty cool. Azure Virtual Desktop is a cloud-based version of Windows that can be accessed remotely. It's scalable, and it's basically a Windows 10 or a Windows 11 deployment. Azure App Service is a service for hosting applications in Azure. It allows you to build web apps, mobile jobs, and RESTful APIs in the programming language of your choice without having to manage the underlying infrastructure. It lets developers focus on building their apps while Azure keeps the environment up and running. The most common types of app service is web apps, API jobs, web jobs, and mobile apps. Azure Virtual Networks and Virtual Subnets enable Azure resources to communicate with each other, with other users on the internet, and with your on-prem client computers. So, Azure Networks provide the following key features: isolation and segmentation, allowing you to create multiple isolated virtual networks. When a virtual network is configured, you define a private IP address space by using either a private or a public IP address range, and the IP ranges only exist within the virtual network. It isn't internet routable. The IP can be subnetted, dividing the virtual network for organization and security, and virtual networks can be configured to use either an internal or an external DNS server. Azure Virtual Networks provide the following key features still: internet communication. Basically, assigning a public IP address allows incoming connections to be accepted from the internet. This can also be achieved by putting the resource behind a public-facing load balancer, which is going to split that traffic out for you. Communication between Azure resources. Virtual networks can connect VMs and other Azure resources. Service endpoints can connect other resource types such as Azure SQL databases and storage accounts. I always said SQL, and everyone says SQL. And I know it's SQL, but I was always told SQL when I first started out, and you know when things just stick in your head like that? Anyway, this basically allows you to link multiple Azure resources to virtual networks to improve security and provide optimal routing between resources. Communication between on-prem resources. So a point-to-site virtual private network that's from a computer outside your organization back to your corporate network. You've got a site-to-site, which links an on-prem VPN gateway to the Azure VPN gateway in a virtual network. And you've got Azure ExpressRoute, dedicated private connectivity to Azure. It doesn't travel over the internet, and it's used when you need a large amount of bandwidth and security. You can also route network traffic. Azure routes traffic between subnets on any connected virtual network, on-prem network, and the internet. You can control these settings through route tables, which allow you to define how the traffic should be directed. Border Gateway Protocol, BGP, it works with Azure VPN gateways, Azure Route Server, or Azure ExpressRoute to propagate on-premise BGP routes to Azure Virtual Network. You can filter network traffic between subnets, basically using network security groups. Azure resources can contain inbound and outbound security rules that can allow or block traffic based on the information that makes the traffic, such as the source IP, destination IP, the port, and the protocol. And network virtual appliances, which are VMs that carry specific functions, such as a firewall or WAN optimization. These are going to be closer to your sort of traditional appliances where you would have a firewall or a WAN VPN, as opposed to the sort of newer Azure resource types. Peering basically allows virtual networks to be linked. Traffic between the peered networks is private. So the main networking features are virtual networks, VNets, allowing Azure resources to communicate with each other. Load balancing, allowing traffic to be evenly distributed between resources. Virtual private network, an encrypted tunnel which is used to connect 2 or more private networks. VPN gateways, deployed in dedicated subnets of a virtual network. Azure Express Route is a dedicated private connection to Azure that doesn't travel over the internet, used when large bandwidth and security are requirements, and Azure DNS, hosting services for DNS domains, provides name resolution using Microsoft Azure infrastructure. Our next demo is going to be for virtual networks. So you want to basically type virtual networks up in the top bar here, virtual networks, cool. You're going to hit create. You're going to choose your subscription, then you're going to choose your resource group. So we're going to choose the ZSEC resource group that we created earlier. We're going to name it, so we're just going to call it ZSEC VNet 1. So ZSEC VNet 1, we're going to do UK South again. So IP addresses, so you're going to do your IP address space here. So basically, we're going to do IPv4, and you see we've got 10.0.0.0/16. So that's actually going to calculate all the addresses here in this range here, which is really, really cool because it just means you don't actually have to check a subnet calculator for it. Well, okay, I'm sure a lot of you networking gurus will be able to know this off the top of your head for anything from a slash like 28 all the way down to /16. But most of them, I don't know them, right? I'll be honest with you. There was a time when I was a bit of a networking person, but I'm not a networking person right now. I just work with Azure and security. So we're going to do the subnet. We're going to do the default subnet name. That's cool. You can add more subnets to kind of break up this virtual network. We're not going to. If you want to do a sort of in-depth, if you want to do like an in-depth network tutorial, we could do that. It's just not this video. It's not covered in the scope of this exam. So you can choose Bastion host. You can choose DDoS protection as standard. You can choose if you want a firewall. And okay, we're going to be blowing all this away after this demo, so we're not configuring this stuff. Most of it's all going to be an extra cost out of my wallet, so we're not going to be configuring that right now. Next, tags again. See if you want to set up any tags. You want to review and create, and it's basically just going to do another validation check again. We can actually check all of it ourselves. We want to do it to the ZSEC Lab subscription. We want to do the ZSEC resource group. It's called ZSEC VNet 1. We've got UK South, we've got 10.0.0.0/16, and we've got a default subnet of /24, and then we don't want Bastion, we don't want DDoS protection, we don't want firewall. We're going to hit create. And it's going to keep loading, and it's going to keep spinning. A lot of the time when you're spinning up these resources, they just take a minute, because, well, it does need to go and spin it all up, so that's why it takes a bit of a minute. But deployment's going to be in progress, and you can basically, a couple of things you can do with this. You can wait for it to be complete, or you can hit up the notifications, and it's going to load once it's done. Cool. So we can see we've got our virtual network, and so now if we go into our virtual network, we can see it, we can configure it, we can add new subnets, we can add DDoS protection, we can add firewall, we can add all this. So anything that you set up is not permanent, right? You can basically add stuff on later. You can add more subnets. You can even change your address space. Like, it's all easy. Like, I can just bin this and I can set a new address space. So, I mean, maybe networking in Azure will be something we'll cover at a later date. It's actually something I need to read up more on myself. But now if you go into your ZSEC resource group, you can see we've got a virtual network in there. So that's pretty cool. Moving on now to Azure Storage Service. So there's several storage services that can be utilized via Azure. There's Azure Blobs, which is a massively scalable object store for text and binary data. It also includes support for big data analytics through Data Lake Storage Gen 2. Azure Files, which is managed file shares for cloud or on-premise deployments. Azure Queues, which is a messaging store for reliable messaging between application components. And Azure Disk, which is block-level storage volumes for Azure VMs. Azure Storage Tiers. There's several tiers of access for blob storage. There's Hot Access, which is data that's accessed frequently. Cool Access, which is data which is infrequently accessed and stored for at least 30 days. There's Archive Access tier as well, which is appropriate for data that's rarely accessed and stored for at least 180 days with flexible latency requirements. In order to access data from the Archive tier, you're going to have to rehydrate that data again before you can actually use it. So for redundancy options in Azure, Azure Storage stores multiple copies of your data to protect from planned and unplanned events. So for redundancy in the primary region, data in the primary region is replicated 3 times, and there's 2 options for this. There's locally redundant storage, LRS, which replicates the data 3 times in a single data center in the primary region, and this is the lowest cost redundancy method, but it offers the least durability. Then there's ZRS, zone redundant storage, which replicates across 3 availability zones in the primary region. So here we've got locally redundant storage, LRS. So you've got your data center here, and you'll see your data is being copied 3 times. Cool. So it's the cheapest, but it's the least durable, right? Because if this data center goes down, we're fucked, basically. All your data's gone. Then when we go to ZRS, we see you've got ZRS here. We've got the data and storage accounts, each within a data center and within the availability zone. So this is going to protect us within a whole region as opposed to one data center. You've got your first availability zone, your second, and your third. So your data is safe unless the whole region goes down, which is pretty unlikely. Okay, then we've got sort of redundancy in the secondary region. So data can be replicated to a secondary region for high durability applications. The secondary region is based on region pairs and it's not able to be changed. So you've got GRS, Geo Redundant Storage, which copies 3 times to a single location in the primary region using LRS, and then to a single location within the secondary region. So you've got geo replication here, you've got LRS here, but it's replicated in the secondary region as well. So if one data center goes down, well, you've got a second data center, and that's the same for the region. If the whole region goes down, then you've got this, and that's pretty cool, right? Then we've got GeoZone redundant storage. It combines the high availability provided by availability zones with the protection from regional outages provided by georeplication. In GZRS, which is a bit of a tongue twister, storage account is copied across 3 availability zones in the primary region and also a location in the secondary geographical region. So you got your primary region here, and you've got your classic sort of ZRS here, where it's zone redundant, and you've got 3 availability zones. But then even if the whole region goes down, so if one sort of data center goes down, you've got these 2 other availability zones. But then if the whole region goes down, well, you've still got a secondary region, which is pretty cool. So we're going to go through different storage account options and storage types. So you've got standard general purpose V2, that's used for blob storage, queue storage, table storage, and Azure files. The redundancy options for this are LRS, GRS, RA, GRS, ZRS, GZRS, and RA, GZRS. This uses standard storage account type for blobs, file shares, queues, and tables. Then you've got premium block blobs, and the supported services are blob storage, including data lake. For redundancy options, you can use LRS and ZRS. And usage, you've got premium storage account type for block blobs and append blobs. Then we've got premium file shares used for Azure files. You can use LRS and ZRS. You've got premium storage account type for file shares only. And then we've got premium page blobs, which is page blobs only. And it supports LRS, and it's a premium storage account type for page blobs. So there's a few sort of services that are offered for larger scale migrations, but for smaller migrations of files, you can use a couple of utilities. So we've got AZ Copy, which is a CLI utility. You can use it to copy blobs or files to or from your storage account. You've got Azure Storage Explorer, which is like a GUI standalone app, which is used for managing files and blobs in Azure storage accounts. It works on Windows, Mac OS, and Linux, and it uses AZ Copy on the back end. Then we've got Azure File Sync, and it lets you centralize file shares in Azure files while keeping flexibility, performance, and compatibility of a Windows file server. When looking at a larger migration, we can use Azure Migrate, which is a service which helps migrate from an on-prem environment into the cloud. We also have Azure Data Box, which is a physical migration service that helps transfer large amounts of data quickly. So a DataBox storage device is shipped directly to you. It has a maximum capacity of 80 terabytes, and once you've transferred the data to the device, you pack it back up in the rugged case it arrived in, and you return the DataBox. Once Microsoft receive the data back, they'll upload it right to the Azure portal. Azure AD is a directory service that enables you and users to sign in and access both Microsoft cloud applications and cloud applications that you develop. Azure AD can also help manage an on-prem AD deployment. AD obviously stands for Active Directory. But Azure AD is for IT administrators for controlling access to applications and resources. App developers can use Azure AD to implement SSO, single sign-on functionality to applications. Users can perform self-service password resets, and on online service subscribers, most Microsoft products allow users to use their Azure AD credentials to authenticate. What does Azure AD do though? So it provides authentication, which basically verifies access to application and resources, provides self-service password reset, allowing you to reset your own password, multi-factor authentication, custom list of banned passwords to basically alleviate those nasty little default passwords that people always use. Like if you want to use like password 2 with an exclamation mark, yeah, you can't use that, sorry, and smart lockout services. Single sign-on SSO allows users to log into multiple applications with one set of credentials. And device management allows devices to be registered to Azure AD, which allows Intune to be implemented, which is another Microsoft solution. It's a SaaS, I guess. This is an MDM solution, which allows you to manage mobile devices remotely. It can be used to set up conditional access, which allows access to be blocked based on various conditions, such as which device the user is logging in from. Active Directory Domain Services (ADDS) provides a managed domain service such as domain join, group policy, lightweight directory access protocol (LDAP), and Kerberos/NTLM authentication. With Azure ADDS, if I can keep saying that, you can benefit from the features of an on-prem ADDS without having to manage domain controllers. When you set up an ADDS domain, you basically define a unique domain name, then 2 Windows Server domain controllers are spun up in your selected Azure region, and these DCs are fully managed by Azure and they don't need to be managed, configured, or updated. So Azure Active Directory is what the demo we're going to be looking at next. So you want to head to Azure Active Directory. Again, you can search up in the top. So you would just do, if I can type, Azure Active Directory. So this is mainly what we're going to be used to actually manage users and permissions in Azure. So if you go to users here, we can actually see ZZig Labs. We can create a new user. So create user, you just buy out their name, both their username, then your regular name, first name, last name, these aren't required, and then you can set groups. So I don't actually have any groups, but roles, you could basically say you want to give them global admin, which basically gives them permission to everything, can manage all aspects of Azure AD and Microsoft services that use Azure AD identities. You can do that. Then you can either choose to block sign in or not. So basically, is the account enabled or not? And then you can actually set information for the user there. So yeah, that's pretty simple as far as users go and setting their permissions. You can set groups for managing users, and this is important for sort of RBAC, role-based access control. And yeah, Azure is one of them. Azure AD is one of those things where it's really, really simple to describe at a really, really, really high level. But the more you get into it, the more confusing it is, and the more you realize, oh, actually, this stuff is quite complex. I remember sitting the MCSA exams a few years back, and there was a whole exam on not Azure AD, but just on-premise Active Directory at the time, which is similar. You can actually sync the two, but Azure AD is sort of where things are moving as people move away from sort of on-prem AD. Obviously, people still run it everywhere, but Azure AD is sort of where things are going in the future. Next, we're going to look at authentication methods in Azure. So you've got single sign-on, which allows the user to sign into multiple resources using one set of credentials. Multi-factor authentication, which prompts a user for an extra form of identification during sign-on process. Multi-factor authentication usually asks for 2 out of 3 of the below categories, being something you know, which is a question or password, something you have, which is a code that expires on a timed basis, and something a user is, like a biometric fingerprint. Password authentication, it basically removes a password and replaces it with something you are, something you have, and something you know. And a few examples below are Windows Hello, which allows you to use a fingerprint scanner on a laptop or facial recognition. A lot of people have that on their phones now. You can get into your phone with just your face. Microsoft Authenticator app, which when a user signs in, a number can be displayed on the screen, and the user then has to open up the app and select the matching number to sign in. Then they have to hit approve. FIDO security keys, which is an open authentication standard that reduces the use of passwords. These are basically USB keys that can be purchased that are used as a token to log in. External identities and guest access in Azure. So external identities refer to a person, device, or service that is outside of your organization. Azure AD external identities details the way you can interact with external factors securely. So with an external identity, the external person manages their own credentials on their side, while the IT admin on your side just has to manage the access. So business to business, B2B collaboration, it allows an external user to use an identity of their choice to sign into Microsoft or other enterprise applications. These users are represented as guest users within your Azure tenancy, or your Azure Active Directory tenancy, I should say. B2B Direct Connect is a two-way trust of another Azure AD organization to be used for collaboration, and currently supports shared Teams channels and allowing external users to access resources within their home instance of Teams. Azure AD Business to Customers (B2C) allows you to publish SaaS and custom web apps to customers while using Azure AD B2C, which is business to customers, for access management. There's a lot of acronyms here, so bear with me, all right? Azure AD Conditional Access. So conditional access allows AD to allow or deny access to resources based on identity signals. These signals include who the user is, which device the user is logged in from, and which application the user is trying to access, and it'll either allow or deny access based on basically those flags. Role-based access control, RBAC. So RBAC is the principle of only giving the users the access they need for their specific role. So Azure RBAC can be applied at scope level, and a scope can be a management group, a subscription, a resource group, and individual resources. It's enforced through Azure Resource Manager, which is ARM, and we'll touch on that a bit later. Usually RBAC is managed via group membership in Azure AD, so your security engineers will also require a different access level to your networking folks, and your support team again will require a different level of access to different resources. So instead of managing permissions on a granular basis for each member of staff, you can manage them via RBAC, which one, it keeps permissions consistent, and two, when a staff member leaves, it allows you to allows you to easily just remove them from the group rather than removing all their permissions, and this keeps all your permissions in line and following a set of rules and requirements. So zero trust basically assumes a breach at the outset. The principles of zero trust are verify explicitly, which basically means always authenticate and authorize based on all available data points. Use least privileged access, which limits users of just-in-time, just enough access. Risk-based adaptive policies and data protection. And assume a breach. Minimize the blast radius of segment access, verify end-to-end encryption. You use user analytics to get visibility and drive threat detection and improve defenses. Next, we're going to be looking at what I think is the final topic in this section, which is the defense in-depth model. So defense in-depth aims to protect information from being accessed and stolen by those who aren't authorized to use it. So it basically aims to slowly advance of an attack that aims to acquire data and uses a layered approach, starting with physical security, working our way into identity and access, perimeter, network, compute, application, and data. So, physical security is the first line of defense to protect computing hardware in the data center. Identity and access, control access to infrastructure and change control, use SSO and multi-factor authentication. Audit events and changes. Perimeter, use DDoS protection. Use perimeter firewalls to identify and alert on malicious attacks on your network. Network, limit communication between resources, deny by default, restrict inbound internet access and limit outbound access where appropriate, and implement secure connectivity to an on-premise network. Compute, sort of implement endpoint protection on devices and keep systems, patches, and current. And application, which is ensure applications are secure and free of vulnerabilities, store sensitive application secrets in a secure storage medium, make security design a requirement for application deployment, and data is stored in a database, stored on a disk instead of a virtual machine, stored on SaaS applications such as Office 365, and managed through cloud storage. We've also got Microsoft Defender for Cloud. Defender for Cloud monitors cloud, on-prem, hybrid, and multi-cloud environments. Defender for Cloud helps to detect threats across Azure Platform as a Service services, Azure Data Services, and networks. Defender for Cloud will assess your environment and provide a secure score based on things it thinks could be recommended or improved. And as you implement these, your secure score will increase. Our final topic, our final module, our final hingy-majiggy, is describe Azure Management and Government, which is going to be 30-35% of your exam. So the functions of this, or the topics of this, are describe cost management in Azure, describe features and tools in Azure governance and compliance, describe features and tools for managing and deploying Azure resources, and describe monitoring tools in Azure. There's a couple of factors that are going to affect your costs in Azure. So resource type, the settings you set on a resource and the region you store it in, that's going to affect your costs. Remember, we're on a pay-as-you-go model with Azure, so consumption, and the more sort of resources you use, the more you're going to be charged. For maintenance, you can actually use resource groups to keep things organized. This helps you to deprovision resources that aren't needed anymore, and that affects your costs and that you make a saving. But if you're not doing that, you're going to lose track of stuff which isn't needed anymore. That's going to basically increase unnecessary spend. In geography, how far away something is, how far the actual data has to travel, that's going to affect your costs. Network traffic, so for leaving the boundaries of Azure data centers, different areas are priced into zones. Subscription type, what kind of subscription you're using, and Azure Marketplace, that can also add to your costs. So there's sort of two different types of main pricing calculator in Azure. So you've got your pricing calculator, which can give you an estimate of provisioning a resource in Azure. So you can get an estimate for an individual resource or a fully built out solution. Then there's also the total cost of ownership calculator, which allows you to compare the cost of running an on-prem infrastructure with a similarly spec'd Azure cloud infrastructure. So it compares the cost of your current infrastructure with a cloud version supporting the same requirement. When it comes time to actually configure and deploy resources in Azure, the pay-as-you-go model can actually be quite daunting, especially if you're someone like me who is spinning up stuff at home and they don't really have 10 grand to spend a month on sort of Azure. So basically with the pricing calculator, you can see how much something's going to cost. So for a virtual machine, for example, you click into virtual machine and basically everything you click, so you can do example scenarios, saved estimates, frequently asked questions. You can sort of sort stuff. So you can do networking. So we could add a virtual machine down here. We could add a VPN gateway. We could add DNS, and we could calculate the price, the sort of estimated price. So we're going to do the United Kingdom South, or that's UAE. No, we don't want that. Okay, so operating system Windows. We're going to do OS only, and we're going to do the basic tier. Oh, which is a lot cheaper. Oh no, it's not a lot cheaper. So category, it's just going to be all, instance all. Here you can actually choose your sort of specs. So you can do 1 core and you can do all the way up to 8 cores, 14 gigs of RAM. You can choose your virtual machine. So let's say we're going to do 2 virtual machines and we're going to be running them for 31 days each. There now you're going to see that's going to cost us $29.76 a month roughly. And that's basically if we go by that. So cool. So now we want to add a virtual network as well. So our virtual machines are still going to be there. That's still going to be saved. Virtual networks. You basically want to set your region. So we're going to set UK South again. We're going to set UK South. Say we want 100 gigs of peering. And we want NAT. Let's say yes, we want NAT. We're going to NAT for 31 days for 100 gigs. And view NAT gateway cost, blah, 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 blah. And cool, we're going to see that's going to be $41.98 roughly a month. I'm in the UK, so I would be looking at pounds, but you can change all that down there. And yeah, so that's cool. So you can see roughly for that virtual network and that VM, roughly we're going to be $71.74 a month. So that's the pricing calculator. In the previous demo, we actually looked at the pricing calculator, but now we're going to look at the total cost of ownership calculator, which is going to be basically comparing what the price of our current on-prem workload is to what's going to be our Azure sort of equivalent of that. And it's not like for like, it's just going to be similarly spec'd. So workload 1, we're going to do Windows or Linux server, physical servers, Windows operating system. It's going to be on a data center license. Which I think basically pertains to like how many VMs you can have under the same licensing. Don't get me started on Microsoft licensing. Let's say we've got 5 servers, procs per server, number of processors per server. We're going to do 4. Cores, we're going to do 4. RAM, each has 16 gigs of RAM. Optimized by CPU, we don't have any GPUs, and we don't have any legacy Windows Server 2008 or 2008 R2. You can then add your databases, you can add your storage, you can add your networking. Okay, so we're just going to add that. We're going to let it all autofill. We're going to storage. We're going to let that autofill. Cool. Next, we're going to do assumptions. So adjust assumptions. Software assurance coverage provides Azure hybrid benefits. Geo-redundant storage. Let's say we want that. And the virtual machine cost basically enable this calculator to not recommend B series virtual machines. So B series virtual machines are basically low cost option workstations. So we're going to say that. Then you basically, to get even more accurate, you want to put in the price of how much electricity costs to run your data center, how much your storage is, your actual IT labor costs, how much time are you guys spend like actually managing physical infrastructure. And here's a bunch of other assumptions. We're going to let them all autofill. Now, you can set your time frame, you can set your region. So we're going to do UK South. And okay, so here it is. It's going to say over 5 years, Azure is basically going to save us £246,738. So you see your on-prem cost, and then you see your actual Azure cost. Now, most of this is probably going to be taken into account like CapEx versus OpEx. And here you're going to see, so we've got hardware costs here, which are the bulk of what our costs here. Whereas in Azure, you're only actually paying for the actual sort of compute. So what you're actually using. It's like the pay-as-you-go model as opposed to physical hardware and paying for your IT labor. You do have IT labor for this one, but it's not going to be as much, right? And so there's a cost breakdown there. So yeah, if you're thinking of migrating to the cloud, or you're considering doing a hybrid cloud where you want to add more servers, but you think it's going to be a bit too pricey to do it in your own data center, well, maybe use the TCO calculator and see if you're going to save money by using Azure. Cost management and billing tool. So cost management allows you to quickly check Azure resources, costs, create alerts based on resource spends, and create a budget that can be used to automate management of resources. Tags. So you can assign tags to resources in Azure. These can be used for resource management, so associating tags with specific workload environments, business units, and owners. Cost management and optimization, so group resources that you want to report on. And then operation management, it allows you to group resources based on how critical their availability is. And security tags, you can mark a resource by public or confidential so you know what security level to apply to it. Tags are basically key value pairs, and assigning a tag to a resource group doesn't apply tag to all of the resources within the group. So resource tags are little bits of metadata that you can add to your Azure resources. So if we go to our VM here, we can add tags. Actually, it's right here. Basically, tags are just like key value pairs. So I could say owner, and I could do Z. And the way you would use this in an organization is basically, you could literally say, look, here's a little bit of metadata, and whenever you configure a resource, we want you to add a tag to say that you're the owner. And that means when something breaks in the environment, we're going to come and speak to you about it, Zed, and you're going to be the one that's going to answer the questions on it. Or we're going to come to you and say, hey, Zed, yeah, we broke this thing that you're responsible for. We're really sorry. And then we'll fix it together. But that's a really, really quick intro to tags. Tags are super simple, but you can use tags to sort of break up your billing. You can also use tags to sort of basically logically add bits of information to, well, resources. So yeah, super, super simple and really useful. Azure Policy. So Azure Policy allows you to remain compliant and be alerted if the configuration of a resource has changed. Resource locking prevents accidental deletion or editing of resources. There's basically two types of resource lock. There's a delete, which authorized users can still read and modify resources, but they're not allowed to delete them. And there's read only, which means authorized users can read a resource, but they can't update or delete the resource. Another feature of Azure is resource locks. So if we head to our VM1 here again, which is going to be our guinea pig for like everything, down the side here you can use locks. And this resource has no locks. So basically you can set locks so that things basically can't be edited or resources can't be deleted are the main two types of locks. So we're going to do VM1 test lock, and we're going to do a delete lock, and we're going to add it in there. So now if I go back to VM1 and I hit delete, apply a forced delete, cool. Things are gonna be orphaned, they're basically saying. I'm gonna delete it with VM. I'm gonna say, yeah, I agree. We're gonna delete, and hopefully this isn't gonna get deleted. I really hope this isn't gonna get deleted. Okay, so it's finished running and it's not been deleted because it's been locked. So that's really awesome. And that works. And it says resource has no locks here, but it's quite a new one. We're going to delete this lock here so that when I go to blow everything away later, I'm not sitting scratching my head as to why things aren't locked. The Service Trust Portal basically provides access to various resources about Microsoft security, privacy, and compliance practices. The portal gives information about Microsoft processes, controls, and compliance. And tools for managing Azure resources. So you've got the Azure Portal, which is a GUI portal, which is accessed from the browser. Azure Cloud Shell, a browser-based shell that allows you to create, configure, and manage Azure resources. It supports Azure PowerShell and Azure CLI, which is a bash shell, and it's accessed via the Azure Portal. You've got Azure PowerShell, which is a shell which can be used to automate repeatable tasks, and Azure CLI, which is functionally equivalent to Azure PowerShell, except it runs bash commands as opposed to PowerShell commands. Azure Arc. So Azure Arc lets you extend Azure compliance and monitoring to your hybrid and multi-cloud configurations. It allows you to manage your entire environments together by projecting your existing non-Azure resources into ARM, manage multiple cloud and hybrid VMs, Kubernetes clusters, which is used for infrastructure as code, and databases if they're running in Azure, use familiar Azure services and management capabilities regardless of where they live, continue to use traditional IT ops while introducing DevOps practices to support new cloud and native patterns into your environment, and configure custom locations as an abstraction layer on top of Azure Arc-enabled Kubernetes clusters and cluster extensions. Azure Resource Manager, or ARM, is actually the deployment and management service for Azure. It allows you to create, update, and delete resources in your Azure account. And anytime you do anything with Azure resources, basically ARM is running in the background. So with ARM, you can manage your infrastructure with declarative templates rather than scripts. This is done via a JSON file. You can deploy, manage, and monitor all resources for your solution as a group rather than individual management. You can redeploy your solution through the development lifecycle to ensure a consistent state. You can define dependencies between resources that are deployed in the correct order. Apply access controls to all services because RBAC's natively integrated into the management platform. You can apply tags to resources logically to organize all the resources in your subscription. And you can clarify your organization's billing by viewing costs for a group of resources that share the same tag. You can use something called ARM templates, which utilizes infrastructure as code, which is when you manage your infrastructure using lines of code. So an ARM template is an example of this. ARM templates allow you to define requirements using JSON, and the JSON is verified before any code is run. So the benefits of this are declarative syntax. So it allows you to declare what you want to deploy without writing out the specific syntax. It gives repeatable results, so deploy and scale resources in a consistent manner. Orchestration, so ARM orchestration allows you to basically deploy individual resources, making sure they're deployed in the correct order. You can actually use modular files, which means you can break your templates down into smaller individual files, and these can be reused in multiple deployments. And you can add PowerShell or Bash scripts to your templates, which actually extends the functionality of your deployments. Azure Advisor evaluates resources and it makes recommendations to improve reliability, security, and performance, achieve operational excellence, and reduce costs. Recommendations are provided and give advice on actions you can take right away, postpone, or dismiss. And recommendations are divided into 5 categories. So there's reliability, which ensures the continuity of business critical applications, security, which is used to detect threats and vulnerabilities, performance, which is used to improve the speed of applications, operational excellence, which is used to help achieve process and workflow efficiency, resource manageability and deployment best practices, and cost, which is used to optimize and reduce Azure spending. Azure Service Health, it helps keep track of your Azure resources. This comes in 3 different services. So Azure Status, which is a broad picture of the status of Azure globally, which informs you of any service outages. You've got Service Health, which is a narrower view of services and regions, focuses only on the services and regions that you're using. This is helpful for looking for comms about outages, planned maintenance activities, and other health advisories because of the authenticated Service Health. You can set up notifications for planned maintenance and other changes that may affect your service and regions. There's also Region Health, which is a tailored view of your actual Azure resources, giving information such as specific virtual machine instances and the health of those instances. Service Health can be accessed by, searching the top bar, and you just go to Service Health, and this is going to show us the actual Azure Health experience. So you can see there's healthy locations is in green and affected locations are in orange. So there's actually no affected locations right now, which means that everything is nice and healthy. You can also check planned maintenance. There's no maintenance events scheduled, basically anytime soon, but you can set an alert for if that sort of maintenance is going to be expected. Health advisories, yeah, we've got none, and security advisories, we've got none as well. You can also see health history, resource health for your actual individual resources, resource type. Let's check. It doesn't let you type. That's very stupid. But we're going to do virtual machines, VM1, and you can see, look, all our VMs are healthy. So it's a very, very happy time. Click into it. There's 2 health events that we can actually look into. We can see at Tuesday, November 22nd, which is today, basically received following information regarding my virtual machine. The basically virtual machine was starting and basically saying that hardware has been assigned to the virtual machine. So that's pretty cool. Azure Monitor is basically a platform for collecting data on your resources, analyzing data and visualizing the data and acting on the results. So basically, you have all the data that's feeding in, and then it's split into metrics, logs, and traces. Then that's split into various experiences. So like log analytics, for example, where you can query logs, or a logic app where you can run your sort of data through a logic app, and the logic app can sort of make decisions in like a flowchart type setup, and then sort of automatically do whatever the action is at the end. So Azure Log Analytics allows you to write log queries based on data gathered by Azure Monitor. This uses crystal clear language, which is KQL, which is really cool. And if you're using Azure, or sort of you're doing any sort of data stuff in Azure, or you're using Sentinel, which is their cloud native SIEM solution, KQL is going to be your bread and butter. Azure Monitor Alerts, so it's an automated way to stay informed when Azure Monitor thresholds are being crossed. You set the alert conditions, the notification actions, and then Azure Monitor alerts and notifies you when an alert's triggered. Azure Monitor is also able to be configured to attempt corrective action. Application Insights. So, an Azure Monitor feature, it monitors your web applications. It's capable of monitoring applications that are running Azure on premise or in a different cloud environment. It supports C Sharp, .NET, VB.NET, Java, JavaScript, Node.js, and Python. Basically, when an application insight is up and running, you can monitor an array of information such as request rates, response times, failure rates, dependency rates, response times, and failure rates to show whether external services are slowing down performance, page views and load performance. I said performance too many times. Page views and load performance reported by users' browsers. AJAX calls from web pages, including rates, response times, and failure rates, user and session counts, performance counters from Windows or Linux servers such as CPU, memory, and network usage. And so that's actually the end of my Azure Fundamentals course. So at really high level, we covered all the content in the AZ900 exam, and I'm hoping it's enough for you to pass. This is basically all my notes that I took when I was studying. Yeah, I mean, outside of that, I think it's going to be enough for you. Just make sure you know the content. It covers all the exam objectives, and yeah, this is it. So if this was useful to you, just please leave a like, leave a comment, let me know what you think. Was it shit? Did you get all the way to the end just to tell me I'm crap? Please do. And yeah, it was a lot of fun to make. I had a lot of fun studying for the exam. I had a lot of fun putting together this course. It's my first time doing anything like this in terms of coursing and trying to teach. And hopefully, as things get more complex, we can do more and more complex courses. This is just the fundamentals where I wanted to kind of learn how the ins and outs of making a course, things I would do better next time I already know, things I would do worse I already know. Yeah, so it was amazing. So if you liked it, yeah, if you can subscribe and let me know what you want to see next. So thanks, guys.